So the first question is that write down the lettering graph of front of each one. Is that right? So question one for 1i, did you which one did you choose?
H.
H. Why didn't you choose this one?
Because that's negative.
Negative gradient. Okay, that's good. Now for the next one, you chose which one?
L. I mean I.
I. Okay. Why I, not D, for example?
Feels like I got stuck on that.
Okay. Just Warren, when you think about this, when you say y-intercept, do you see that here?
Yeah.
What's y-intercept here?
That would be
-2. Is that right?
Yes.
-2.
-2.
Yes. Why is that is -2? Because when you say x0, y equals -2. Yes, that is what it is. Yes, that's what we really. Why that is y-intercept? Because when you put x0, y equals -2. When you put x0, what do you get?
-1.
Okay. So is it that one or this one? That one. Yes, is that right? So that is D. Yes, is that okay? So think about it. That is still a bit of, still that last number still is like a y-intercept basically. Even that's like quadratic. Next one, which one you put that one up for? A. Okay. That's positive, so that's why the A is the right answer. So complete the table and then do the graph. So that is that. Yes, are you happy with that one? You're happy with this. Complete the table of that and do the graph. With that, you get. Is it the one? Okay. Okay, happy with that one. Now we go to the next one. 4 similar to that, but passes through 0 and 0. Next one is similar, passing through 0 and 1. Is this the 1, 5, 0 and 1? If you put x0, what is y? 1, yes, 0 and 1, that's it. Yes, that passes through that. And the next one you have, that is right. That is right. I just want to have a bit of explaining about this, just a bit. If it was just y equals x, what is that? So that would be something like that, straight line, y equals x. If it was y equals 1 over x, what is that?
It would be
something like this. Yes. Now, if you look at what you have drawn, wherever you have, if you this y plus that y adds up to that one. This y plus that y adds up to that one. This y plus that y adds up to that one. So if you can see graphically that this plus that makes that. Yeah, do you see what I mean? On y's, yes, you can see that that also happens. So that just so you can see in future if you wanted to cross check. So are you comfortable with the topic that we did last time about these limits? About those limits on infinite, minus infinite, plus infinite, and things like that. Did you review those topics?
One thing that it takes like a bit of thinking to understand what happened with negative and positive influence.
But okay, could you review that? Because you see, some of the things in here are, something like this is not in GCSE. It's not directly given in GCSE, but this helps you to solve much more complex problems if you had a very high level question. Yes, do you see what I mean? So, So if you have a bit of review, if you have a question, just could you let me know. Is that okay? Yes. So when you have something like that, or this, or you know, these forms, what I really want, and when I say these forms, you see, if you have a high-level question, just to give you an example, if you had a very high-level question, could be saying, okay, do this, or where do you think that's going to be? Just to give you an example, what do you think that's going to be? Okay, you see, something like that, for example, when this is not defined, generally. So when we had a case like these, this, yes, when this is not defined, that is not defined when x equals 0. Because we cannot divide a number to 0. Yes, you get a mass error. Is that right? And that's why when we were around 0, we said, okay, instead of 0, we are going to say, okay, what's happening just before 0 and just after 0. Yes, is that clear what I mean in here? Is that right? Because x equals 0 was not defined because x equals 0 was making this denominator equal to 0. Is that clear? We cannot define. If I just say 5 divided by 0, no, there's massive. So when we look at a question like this, so where is this not defined?
0.
Sorry?
5.
X equals 5. So if x equals 5, this is not defined. So if the x is 5 in here, on that line, this is not defined. Yes, on that line is not defined. If it is 5, close to 5 on the positive side, this would make close to 0, and that would be a plus infinite coming from here. And if it was close to 5, less than 5 but close to 5, this would make a negative small number, so that would be a minus infinite. Is that right? And if we say x goes to plus infinite, this still goes to 0, so that is still going to... So because if x is plus infinite, this would be infinite, 3 over infinite would be still 0. If x is minus infinite, this would be minus infinite, 3 over minus infinite would be still 0 on the minus side. Is that right? So this, all of that moves 5 to the right. Okay, is that right? Just think about that again. Just think about why we do that. Why is that why we get these lines? Why do we get this? Why do we get that? Because y equals 0 is not defined in here. Because 2 to the power of nothing makes this 0. Just as an example. Why do we get these? Because x equals 0 is not defined. And if we rewrite that, we can even say x equals 2 over y. So y equals 0 also not defined. So it would never touch this line, and it will never touch that line, which are x and y axis. So that's why you get one like that and one like this. Okay, so could you think about a bit on a higher, from a higher level math? This is not about 6, 7 questions. These are about high level math questions. Okay, so could you think about that, please? Yeah, is that okay? Mm-hmm. So I want to look at completing square today. Have you looked at it before together? But you have it in school, yes? You can. A while ago. Okay. Can we have a review on that one? Have a look at some of the questions. Look at this one. Normally, sometimes the question does not say that use completing square. It just says express that in that form. Is that right? So, but you should know that that is just completing square. Okay. So could we solve the first one? So, okay. Do you know what is the basis of completing square? What is the basis of completing square? I'm going to write the basis of what is completing square, because this is, as I said, there are some stuff that in a high level we need to. Okay, the basis is this. Yeah, is that right? That plus with that plus, and if it was negative, that is negative. Yeah, is that clear? Yeah. That's the identity. That's the identity, same as difference of two squares. Yeah, difference of two squares. A squared minus b squared equals a minus b times a plus b. See, these are identities. That's the identity that you have to know because you use this for factorizing and things like that. But this identity may be not directly in the CSC, but if you're writing on a high level, you should know and use it. Yeah, is that okay? So, now, okay, just I will go through one of these questions. So when I say x squared, when I look at this problem, yes, equals, what I'm saying in here is that I'm going to assume the first two, and for a second, ignore the minus 3. I'm going to assume, because this is plus, I'm looking at the plus part of this. I'm going to assume that this x squared is a squared, and 10x is 2ab. 10x is 2ab. If x squared is a squared, what is a?
X.
X, okay. So when we come to here, this x is that a. Yes, is that right? So what is 10 then? What is that 10?
And 2 times b.
2 times b. So from here, basically b is 10 divided by 2, which is 5. Yeah, is that right? b is 10 divided by 2, which is 5. Now, if I want to make that happen, because that is a complete square, so that is a complete square, what do I need to add there?
B squared.
Which is 25. So basically, x squared plus 10x plus 25 minus 25, because you're adding that taking away as well, equals. Now, what you have done, you have made this a complete square, because based on that identity, now that is equals to x, a plus b squared. Is that right? X plus 5 squared minus 20. Is that right? So x plus p is 5 and q is minus 20. Okay, is that all right? Do you see the basis for completing square? We just really need to be able to look at, use the identities and see the reasons why we do things. Okay, could we look at the second part? Solve, hence or otherwise, solve that. So that's equal to 0. Could we solve that one? Okay. There's something not completely there. One thing that is not complete. It wasn't that, it was okay, just one small thing that you need to do. Okay, when I say x squared equals 9, what is x equal to?
3.
Not 3. Plus minus 3. Because minus 3 times minus 3 makes 9. 3 times 3 makes 9. You see, both of them are answers. So when you come in here and square root both sides, when you do that, you need to write x plus 5 equals plus minus square root of 28 plus minus 3. That's the same thing. You know, you can write plus minus square root of 9. That's still the same thing. See, that's the same. That's what we are doing here. And then do minus 5 both sides. X equals minus 5 plus minus square root of 20. Your final answer is right. You knew that this is going to be answered, but you didn't know how that is coming from, where that is coming from. Is that clear? So do you see that where that you missed what? What did you miss?
The
Plus minus in the second part. Yes. When you square root anything, it's not just about that, anything like that. You see what I mean? Is that right? Just think about it. Okay, could we do one more, please? Could you this time look at maybe this this one here? Okay, that's fine. That's good. Okay, now we go to one that is a bit different, and Now we look at this last question here. It says write 2x squared plus 3x minus 2 in the form of that. So it has a bit, this is a bit different because now there's a 2 in the back of that. Yeah, is that right? So what do you think that we should do this time? Okay, you can't just divide by 2 because you can't say, for example, a equals a divided by 2. Yeah, do you see what I mean? So we can't just divide by 2. What can we do to get that right, do you think? I start this off in here and I leave the rest of it to you. So 2x squared plus 3x minus 2 equals. We can leave the last one again on its own. We don't really need to do things with that last, the number there. But in the first two, I can factorize 2. Yes, is that clear? So factorize the 2 from the first two. Okay. I need your brain to be completely organized. That is, you're trying to do something, and that is what I want you to overall improve when you do algebra. Okay, try to keep the steps in a bit. Okay, otherwise you can make a mistake. Okay, so that is not right. Could you try a bit more? Could you see what's happening exactly? Okay, I just help you. Just leave the rest of it in that bracket. What would be that bracket? Could you write it in here? Equals what? So what can you write for that bracket? No, what is that? A plus 1? I don't get the plus 1. Just leave the rest of it. Just say that that's equal and what? So just to give you an example, what was x squared plus 10x equal to? It was equal to x plus 5 squared minus 25. Yeah, is that right? What was x squared plus 6x equal to? It was equal to x plus 3 squared minus 9. Did you get what I mean in here? Yes? So what is this equal to?
X plus 3 over 4 squared minus 3 over 4 squared.
Okay, still not completely there. I have to have a bracket in here. Do you see what I mean? The precision, has to be a precise thing. So if you don't put that bracket, that would be read as 9 over 4. With that bracket, that is 9 over 16. Is that right? So, okay. So write it in here. So x plus 3 over 4 squared minus 9 over 16. You can do it like this because that squared is 9 over 16. Yeah, is that okay? Now, you see, when I say organization, that's what I mean. Now, what I would have liked and I'd like ideally to do Rather than doing this separately, doing that in there, but replacing that in that part where the bracket is. Do you get what I mean in here? Because you said that this is equal to that. Yes, is that right? Can you write that, replace it that where that bracket is? And can you think about brackets as well? I need to get the brackets right. Okay, can you rewrite that? No. Okay. While I'm asking to do the steps, please, just replace that in here. Don't do anything else. Just replace that. I don't want you to do some steps further. Just replace it, please. Okay. That is all I want in here. I want to see those brackets, and I want to see the other bracket inside. That is what I want. So that is your answer in here, 2 and 9 over 16. Is that right? Now, I want to show you why that could be a wrong answer. Now, after doing that, if you now expand that to, what do you get? 2 times
x plus 3 whole squared.
2 times 9 over 16. Did you see what I mean? So was that wrong?
Yeah.
Yes. Why was that wrong? Because you didn't take the step. You see what I mean? Just right. You just need to do one more right. You don't need to do few things together. But that adds the chance of making mistakes. Okay, is that right? So what's the final answer? So we don't want to solve it. Just is write it in that form. So final answer would be, we can just add just those two, and that's the end of it. So. Okay, 18 over 16 is 9 over 8, which would be 1 and 1 over 8, so minus 3 and 1 over 8. Okay, so that's a simplified form of it. Okay, minus 3 and 1 over. Yes, happy with that one? Okay, so that was the answer for part 1. So do please keep that organizational thing, organization when you do algebra, so that's very important. Get the brackets right and things like that. Now, use your answer to part A to give the coordinates for the minimum point on the graph of 2x squared plus 3x minus 2. What we are doing? Are you solving it? You're not solving it. We don't need to solve it. We just need to look at this, the final form, and say what would be the coordinates of the minimum point. Okay. The coordinates of minimum point here is and minus 3 and 1 over 8. So whatever we get in here is an opposite sign. So it's like we putting that equal to 0, and what do you get? That's going to be minus 3 over 4 for x. And whatever that is a y. So minus 3, 3 and 1 over 8. So that's a y. That's a minimum point. That's a minimum point. Is that okay? Now, I want to explain why that is a minimum point. Yes? And we can do it in different forms, but one of the interesting things that I want you to think about is, and this is one of the things that we will be covering soon, so maybe we can have a bit of a look at it today, is transformation. Transformation. So the things that we had in here, I'm going to write that. So that is the last answer that we had was y equals 2 times x plus 3 over 4 squared minus 3 and 1 over 8. Now, what I want you to think about is, just imagine that this is xy, and I'm going to start with saying fx equals x squared. Yes? Could you draw fx equals x squared with this pen? Okay, approximately that, that's fine. Now, the next one, we change the color. This time I want, first of all, for you to tell me what is f of x plus 3 over 4? What is that? F of x plus 3. I write it in here first. What would be that? Okay, think about it. That is fx. Is that right? F of x equals x squared. What is f of x plus 3 over 4? Okay, is that right? So that is that. So could you now f of x plus 3 over 4, considering that fx is that, so that was fx. This is fx. Is that right? Now, could you draw f of x plus 3 over 4? Where would be that from? Okay, you want to draw that, yes? That's wrong. When we have a plus, moves to the left. When we have a minus, moves to the right. Is that clear? Yes? So this is plus 3 over 4. So with the same color, this point is minus 3 over 4, and that is f of x plus 3 over 4. Is that clear? Yes? So when it's plus, moves to the left. When it's negative, moves to the right. Okay, is that right? Now, again, we change the color. This time we say, could you, this time, first of all, write it in here. What is 2 times f of x plus 3 over 4? So what is algebraically, what is that equal to? Okay, that's one bracket is fine because it's the same. Is that right? So now, what would be the drawing of that in here? So again, considering the previous one, 2 times that. Okay, is that what you think? Okay, why?
Because since it's the 2 times it's making
Yeah, 2 times, yes.
Since it's making it larger, then a smaller change will make a bigger change.
Okay. Just no, I want to give you a bit more clearer, a bit maybe. This y is, how much is the y of this point? Show me the y of that point.
2.
2, about, yes. So where would be that after this transformation?
4.
4, because that's a 2 times that. Is that right? So that point will go here. That point is 4, will go maybe here. What about this point?
Also the same.
So it's same. And as you can see that I wanted just to show why. Yes, is that right? To clearly show why is that's happening. Yes. So that is 2 f of x plus 3 over 4. Is that clear? Now, my last one is this. What is 2 of f of x plus 3 over 4 minus 3 and 1 over 8? So what is this algebraically? Okay. Now, if that's algebraically, so compared to the previous one, we just added that. Is that right? So where is now the new graph? What is affected? X is affected or Y?
Y.
Okay. So why are you saying right or left? So where is that? What's going to happen?
It's going to move up to
What is happening to Y? Okay, you said Y affected. What is happening to Y?
Y is increasing at every point. Y is increasing.
Where is the increase? Show me the increase. Where is the increase in here?
Since x is getting smaller.
We're not doing anything with X. What is the difference between that and that?
3 over 1.
What's that? Is that increase?
No.
It's a decrease. So if the Y was previously that, now is that. So what happened to Y? Why you just think about it, look at it, please. Okay, we will cover this, that's fine, but for now, just I want you to see the difference. So what is happening? Okay, so where would be the graph? So something like that. What would be the coordinate of that point? That minimum point. Okay, so the coordinate in here, minus 3 over 4 is x, and minus 3 and 1 over 8. Is that right? Minimum point. Is that clear what happened? Yes. So I have this question. Does that 2 make any difference in the coordinate?
No.
No, because when we added that 2, it's just that point did not change. Is that clear? Because that 2 did not change, does not change that point. So you should not be confused by presence of any number in here. Is that clear? Yes. So minus of that, because x moves in opposite sign, so if that's plus moves to the left, is a minus moves to the right. Minus of that, and this is y is on the right side sign. So if negative moves down, positive moves up. Is that clear? So I think with this example, so we will come back to this transformation and we will review that a bit more detail and things like that. But I just wanted to have a bit of look at here and see the relation between that finding the minimum point and also this transformation, and also a bit of review of transformation. I think now you should be able to, for Any question, if they say do the completing square and then write the coordinate of the minimum, you should be able to do that. Yes, okay, is that all right? Happy with that one? Okay, so I think we are happy for now with this one. So, have we covered the equation of a circle?
Stuff like the radius and center.
Yes, have you, so we can have a bit of quick look. So we haven't in here covered. So if I say there's a circle here, this coordinate in here is 2 and 3, and the radius is 5. So what is the equation of that circle? Okay, is that the equation of the circle? Yes? Okay, not completely there. Okay, we always in equation of circle, the number at the end is r squared. The number at the end is r squared. So what we are saying in here for the circle, with center A and B and radius r, the equation is x minus a squared plus y minus b squared equals r squared. Yes, happy with that one? Yes. Now, what do you think that this is equation of? X squared plus y squared minus 10x plus 12y minus 1 equals 0. What do you think that this is the equation of? Sorry? That is an equation of a circle. That is a equation of a circle. Just think about what we just learned today on completing square. Instead of this and that, what can you write?
X minus 5.
Squared minus 25. Instead of this and that, what can you write?
Y plus
6 squared minus 36. And then we have minus 1 equals to 0. If we move everything to the other side, we will have x minus 5 squared plus y plus 6 squared equals 62. Is that right? So this is a circle with a center of 5 and minus 6. Center. Happy with that one? Yes, center of 5 and minus 6. And radius of square root of 62. Radius of square root of 62. Okay, happy with that one? Is that right? So that is a question of a circle. So you may be in some questions basically have a bit of circle and have a bit of completing score and things like that to get combined questions. Yeah, is that okay? So could we please, we have to be there all the time. So we shouldn't forget about this sort of small points and things like that in here. Now what I want to now bit of do, and then we sort of go over the algebraic parts, and we look at some other things, is just some more algebraic fractions, and that we would do. And I want to do one question here. For example, this. Okay, not that one. So what about I say we look at that? Okay, let's just fully simplify this for now. So can we look at that? If you say fully simplify, I want to say 1 plus x plus 4 plus 2 over x minus 4. If we fully simplify that algebraic fraction. Okay, so your final answer is
9
no, you don't need to if it doesn't simplify. Okay, that's fine. So I'm looking for a question that I can't completely find. For now, just give me a second. I just want to do one question from here and then we move on to functions 26. This one. So, what about the I think that is also okay. Okay, I think I'm going to do the question myself. So, what about we say, let's say solve that, solve. So this is a bit, sometimes you might have a question like that. So what would you do with that sort of question? Okay, it's not completely right. Just think about what you're doing. Okay, can you think? Can I indicate? Because this sort of thing, it would be the hardest you could get about in this algebraic fractions. But you could get this because this is not something that you haven't covered. When you did that to this, is that this is what you did to that? Is that you time both sides by x plus 1? Is this equal to that? Is that equal to this? Yes. Why is that? I needed confidence. Okay. Yes, because the time both top and bottom to the same thing. Is that it? The same as saying 1 over 2 equals 2 over 4. That's it. Yeah, that's yes. Now, that one and this one is the same as that one?
Yes.
Yes. So you time top and bottom to x plus 4. Yeah, that's what you have done. So if this equals to that, so what is this?
1 times.
Why are you timing 1 times something? No. Is this equal to that? Is that equal to that? So what should be that? Just 1. Did you change that? Did you change that? No. So that's not changed. Do you see what I mean? I think where the confusion comes is when you are a bit two-sided. You are doing two things, but you're doing both of them. But you have to do one of them. You see? And that causes issue. One method of solving this is just basically doing a common denominator as you are doing and just writing 1 and just going again, writing 1 and then timing both sides to that. Is that clear? What I mean? That's one method, which is not a perfect method. The perfect method is the one that you are trying to think about, that is also part of what you're doing, is that when you look at that, in a first instant, just say, I am going to time everything in the left and in the right to x plus 4 times x plus 1. Is that clear? Yes. I'm going to time everything at the left and the right to x plus 4 times x plus 1. Now, when you make the decision to do that, when you time this by that, what you will have?
X minus 1 times x plus 1.
Good. So you don't have this. Is that right? So you just have that. Plus. Now, when you time that to the second one, what do you get?
X plus 4.
Good. And then that is the time that you do, okay, 1 times also that, which would give you x plus 4 times x plus 1. Is that clear? So this is the simplest, quickest method. But the way that you are writing here and then writing there, now you need to go in here and say, okay, I time now both sides by this times that, and then 1 times that gives that, and the left-hand side is what you have in here. So rather than doing all those 3 steps, you do 1 step and that does the job. Is that clear? Yes, is that right? So the rest of this is expanding that, expanding that, expanding that, and moving everything to one side. You have a quadratic equation and solving that quadratic equation. Okay, happy with that one? Yeah, is that right? So could you think about that? So I want just make a decision what you're doing exactly. Have a logical reasoning. Okay, you didn't change that. You didn't change that. Why are you timing that to this? You see, if something like this would take about 10 minutes of your exam time, and it will be a wrong also on that end. Why is that? That mistake results now, if you time both sides in here to this times that, would give you x to the power of 4. Because you have x squared here, you have x squared here, and you see x squared times squared would give you x to the power of 4, and x to the power of 3. And it's basically a non-solvable equation. Do you see what I mean? Just because of that one mistake there. Is that okay? So, and as I said, because it's non-solvable, it would take 10 minutes because you're just trying to write and write and write and write, and it just doesn't go doesn't go anywhere because there's a mistake in it. Okay, is that okay, Brian? So could you think about that? Be precise and see, just reason it with yourself what you are doing exactly every time. Okay, that's okay. So I want to. I think we finish for today. We will start direct and indirectly and inversely proportional. So that stuff next week. Okay, and then we take it from there. But on algebra side, I think we